All right, moving on to question 2c. It says Marie buys a new car for $24,990. The car's value decreases by 12% per year. So let's write some of this down as we go. So if I'm increasing it, decreasing, saying decreases, that's going to be 1 minus 12%, which is 0.12, which is equal to 0.88. So I'm just going to jot these things down as I go through. The value of the car, PT, is after you bought it, can be modeled by the function blah, which is the normal function we use for decreasing percentages. So let's have a look. It says how long will it take for the car value to halve. So the p-value is the half bit. So let's say we got 12, and we could just write a half here, but I'm actually just going to write 24,990. Oops. 990. I'm going to divide it by 2. There it is. And it's 12,495. So I'm going to have 12,495 is equal to 24,990. And you'll see in a moment why I could have just written a half. Times R, well, so there's P value is that, A value is that. The R value is the rate at which it's decreasing. So for a compound interest decrease is 0.88, and it's all to the power of t, which is the time it takes. We're going to say how long will it take for that to happen. All right, so first thing I'm going to do is I'm going to divide everything by 24,990. Divide by 24,990, and you'll see how this suddenly plays out. So obviously that is 1. Now, but 12,495 divided by 24,990 is 1/2. So I could have just written that a half is equal to this thing over here, 0.88 t to the power of t. So now I'm going to find the log of both sides. I didn't leave myself a lot of room on this side, so I'm just going to rub this out here. And I'm going to put here, put log 0.88 to the power of t. And I'll put over here log 1/2. So I'm finding the log of both sides. So I've got log of a half. I can leave that as log of a half. But here I'm going to have the coefficient of this now becomes a t. So the t can move out in front. So it's going to be t log 0.88. Because this here is the same as this here. I can either put it as a power of the log or the index of the log, or I can take the index and put it out as the coefficient of the log. Same deal. Now, I wrote a line under that, so I'm going to take use of the vinculum, and I'm going to divide this by log 0.88, and I'm going to divide this by log 0.88. Here we go. Of course, that divided by that is a 1, and t is going to be the time. So let's have a look what that would be. So I'm actually going to use, put it straight into the calculator. So here we go. So we've got the log of, I'll put log 0.5. I'll use decimals here, and I'm going to divide the whole thing. In fact, I'm going to put that in brackets. Log 0.5, so I don't end up halving the 0.5. And I'm going to go brackets log of 0.88. See how that takes me. And I get 5.42. So t is going to be 5.42. I'm going to write a few. I'm going to actually write all these DPs out. 222. It's got a 7098. You should write the whole thing out. Much better idea. And then so now let's whittle this down to, so let's say 3dp or 2dp is 5.42. Now the time is in years, so I'll put years here, and I put 2dp. Now it doesn't ask for it in years and months. This is how long. So I'm just going to go with 5.42, or you could actually throw in more DPs if you want, but yeah, over to you. But that's the way which I would do it. You could argue that it was well, more than 5 years, so therefore you could say, well, how many years would be 6 years, because you'd probably have to wait till the end of the 6th year for all this to play out. But just as a raw answer, I would say that would be what you're after. Hopefully that makes sense.